Hi guys, and welcome back. So today we're going to do another cool problem involving compound interest. So if you're watching this video, that means you watched the fun problem number 1. I hope you did. If not, please go back. Okay, today we're just going to assume you're cool with the formulas. So just to recap, there are different ways to calculate interest. One of them is simple interest and another one is compound interest. We have two formulas for compound interest, okay? One that reads A equals P times 1 plus R over N raised to the NT power, and another one that reads A equals P times E raised to the RT power. And the question is, which of the two compound interest formulas do we use? Well, that depends, okay? If you have like a finite or a fixed number of compoundings, then you're going to use this longer one, okay? But if the problem says that the interest is compounded continuously, then you're going to use this short one, A equals P times E raised to the RT power. Okay, so that was a good review, okay? Let's go ahead and knock out this fun problem. So it says, Panchito wants to put some money in an online savings account and leave it there for a while. How much money will there be in an account at the end of 7 years if $3,000 is deposited at 3.5% compounded as follows? Assume no withdrawals are made. Okay, so we have 4 problems. The first one, Bank of Maria. Yeah, cool. Interest is compounded yearly. Okay, what's so special about piggy bank? Interest is compounded monthly. Okay, bank number 3, the extra credit union. Interest is compounded daily. Bank number 4, WeBank. Interest is compounded continuously. Okay, so for all 4 case scenarios, there are a few things that are gonna hold true. I mean the same. Okay, second sentence. How much money will there be in an account at the final amount at the end of 7 years? So we know that time is 7 years. If $3,000 is deposited, so 3,000 is our principal. So principal is the amount we invest, deposit, or borrow. At 3.5%, that is our rate. Compounded as follows. So for all 4 banks, these 3 things are going to be the same: the time, the principal, and the rate. What will differ is how often is the interest compounded or paid out per year. Okay, so you can either write bank number 1 or you can put the name of the silly bank. Okay, I'm just gonna put bank number 1 or Bank of Maria. I'm going to write down the facts, okay? So the question is, how much money will there be in an account? So what is that final amount? Remember, we're going to use that compound interest formula. Let me write it somewhere on the side. So we have A equals P times 1 plus R over N raised to the NT power, okay? So where A represents that final amount or ending balance, that's the principal plus interest. P is your principal, R is the rate, N is the number of times that the interest is compounded or paid out per year, and T is the time. So let's go ahead and write down what we know. Okay, so we know that the time is 7 years. The principal is 3,000. The rate is 3.5%. While we're at it, let's go ahead and put it in decimal form, 0.035. Okay, so those 3 things are going to hold true for every bank. Okay, now it says compounded as follows. So for Bank of Maria, the interest is compounded yearly. If the interest is compounded yearly, then that means that they pay out the interest only once per year. Okay, so with the little detective skills, we're like, oh yeah, interest is compounded yearly. That means that they pay out the interest only once a year. So remember, compound is the number of compoundings. That's just code for how many times do they pay out the interest per 1 year. All right. So we wrote down the 3 facts. We wrote down N. Let's go ahead and write down the formula. So we have A equals P times 1 plus R over N raised to the NT power. Yeah, you can put this in your note card, but believe it or not, you're gonna write this problem, this formula so many times that you'll probably just memorize it. Okay, so let's plug and check. So we want to know how much money will there be in an account. So what is that final amount? So that final amount is, our principal is $3,000 times 1 plus R, where am I? The rate is 0.035 over n, which is 1, raised to the nt power. So n is 1 and t is 7. Okay, at this point you can go straight to answer, but I'm going to simplify this sum. If it gives me something nice, like something with not terrible, something with not too many decimals, sorry, then I'm going to write it. Okay, quotient of 0.035 and 1 is just 0.035, and 0.035 plus 1 is just 1.035. Again, if you just want to go straight to the answer, because it's just straight straight computation, go for it. So that is 1.035 raised to the 1 times 7 is 7, and that is being multiplied 3,000. So I said it before in the earlier video, whenever possible, I like to evaluate parts of the puzzle to minimize the number of keystrokes that I have to do in one swipe. So let's do this. So let's see what that final amount is. So we have, where are we? 3,000, 1, 2, 3 times 1.035 raised to the raised to the 7th power. Okay, so we are talking about money, dollars to be exact. So let's go ahead round to 2 decimal places. I'm a terrible rounder, so I'm gonna put the 2 decimals and then we'll put the third one to help us round. Okay, 0.837. I'm not a terrible rounder, it's just I like to circle things and I can't circle my calculator. Okay, so let's go ahead, identify the digit that's in the rounding place. And let's go ahead, identify the rounding digit, which is a digit in the hundreds place. We're going to look right next door, and in this case we're going to be rounding up, so it's something and about 84 cents. So we round up, anything before it will stay put, and we're going to ignore the remaining decimal digits. Okay, so the final amount at sorry, I need to write and then speak. Okay, the final amount at bank number 1 or Bank of Maria is $3,816.84. That's pretty neat. We started with $3,000, and after 7 years we have, you know, a little more than $800 in interest. Cool. All right, so 1 bank down. Where am I? 3 more to go. Okay, so we have bank number 2. Let's go ahead, write down the same 3 facts that are the same, which is the time, principal, and rate. Okay, so we have that the time is still 7 years, the principal is still $3,000, the rate is still 3.5%, in decimal form is 0.035, and remember to pause and rewind as many times as needed. Okay, now what else do we know? Nothing. Well, I have to read it. Okay, so bank number 2, or at piggy bank, we have that the interest is compounded monthly. So I'm like, oh, how many times do they pay out the interest per year? If they do it monthly, well, there's 12 months in a year, so that means that they pay out the interest 12 times in a year. So interest is compounded monthly is code for n equals 12. All right, so let's go ahead and put that in our problem. So we have n equals 12, and then let's just go ahead and write it out. I'm gonna write down the formula below because I want to have space for like everything on this page. Okay, so we have compound interest formula. We have A equals P times 1 plus R over N raised to the NT power. That's it. We did one of the toughest things, which is spitting out that formula. Let's plug and chug and find the final amount. Okay, so we have that the final amount is given by the principal, which is 3,000, times 1 plus R over N. The rate is 0.035. and the interest is compounded 12 times a year. Okay, raised to the NT, so N is 12 and T is 7. Okay, this is enough work. Okay, the rest is straight computation, so you can go straight to the answer. But let me see if I can get a nice decimal, not equivalent. Let's go ahead and add. So we have 1 plus 0.035 divided by 12. That is too many decimals. We don't have the certainty. Well, this is not even 7. It's actually 6. It's 1.029166666, you know, scary number 6. So no, we're just going to leave it as a sum. Let's just go straight to answer then. So we have that the final amount equals, let me clear this, we have 3,000 times, but I'm going to go ahead and use the open parenthesis, 1 plus 0.035 fraction bar divided by 12, close the grouping symbol, exponent raised to the, if you're good at math, 12 times 7 is 84. If you're like, I don't want to risk it because I'm too tired, then just go ahead and enter the product, 12 times 7, but don't forget to wrap it up, okay? And then that will give us something with a lot of decimals, so we're going to have to round. So the final amount is about 3831.49 and a bonus 1 to help us round. So we're going to identify the digit that's in the hundreds place. We're going to look right next door, and in this case we're going to have to round up. So we had about 49 cents plus one more, it's going to be about 50 cents. Okay, so all the digits before it will stay put, but then we're going to ignore the remaining decimal digits. So that's about $3,831.50. So if we go with Bank of Maria, our $3,000 will turn into about $3,800. If we go with Piggy Bank, our $3,000 will turn to about $3,800, but I should say it exactly, you know, 3816, and this one is a little bit more. So that's pretty interesting. The time, principal, and rate are the same, but yet we get different final amounts. Well, that's because the number of compoundings are not the same. All right, 2 banks down, 2 more to go. Bank number 3. Let me just write down the 3 things that are the same, which is the time, principal, and rate. Time is 7 years. Principal is $3,000. And then the rate is 3.5%. In decimal form is 0.035. Okay, so these 3 ingredients are the same for all 4 banks. What differs is the number of times that the interest is compounded or paid out per year. In this case, for bank number 3, which is, where am I? It's the Extra Credit Union. We have that the interest is compounded daily. I'm like, all right, cool. They pay the interest daily. So how many times do they do it per year? So if the interest is compounded daily, that means that they pay it 365 times a year, because there's 365 days in the year. So let's bring that to our solution. So we have n equals 365 and a little separator. All right, let's go ahead and write down the formula. So we want to know what the final amount is. So we have A equals P times 1 plus R over N raised to the NT power. So we have at A, or the final amount, is given by the principal of 3,000 times 1 plus R, which is 0.035 over N, which is 365, raised to the NT power, which is 365 times T. With your permission, we're just going to go straight to answer. I mean, if dividing 0.035 by 12 gave us something funny, like too many decimals, if we divide by 365, we're also going to get something funny, too many decimals. So we're going to go straight to answer. So the final amount when the interest is compounded daily is, let's go ahead and move this. Cool. So we have 3,000 times, we'll put open parenthesis, 1 plus 0.035 divided by 365, 0.035 divided by 365, close that grouping symbol, raised to, I have no idea what 365 times 7 is, so we're just going to write it as the multiplication problem. 365, make sure you put a open parenthesis, 365 times 7, times 7, close the exponent, or close grouping symbol, hit equals, and we have 3832.81 plus one more to help us round. So in this case, we are also going to round up. So that's going to be about something and 82 cents. So we have 0.28238. I think I said it wrong. Okay. So the final amount, I can't squeeze in a dollar sign, are $3,000, or it's going to turn to $3,832.82. And look at that, we had a 31 cents, now we got 32 cents. What changed? It's the number of times that the interest is compounded. So I see a pattern. If n equals 1, we got that much. If n equals 12, 38.16, we went from 38.16 to 38.31. And if n equals 365, we went from 38.16 to 38.31 to 38.32. So the moral of this story is this: the more times that the more often that the interest is compounded or paid out per year, that's gonna give us more money in interest. So yeah, all right. Bank number 4. What is going to be that final amount at the end of the 7 years? So we're going to copy what's the same for all 4 problems, which is time, principal, and rate. Okay, so the time is still 7 years. The principal is $3,000. The rate is 3.5%, in decimal form 0.035. Now the $1 million question: how often is the interest compounded? Okay, so for the 4th and final bank at We Bank, interest is compounded continuously. That is a trick question, because that doesn't make sense. Like, oh, like n equals 1, n equals 12, n equals 365, or n equals something else. If the interest is compounded continuously, then we cannot use this formula. This formula is for finite or fixed number of compoundings. We're going to have to use this exclusive formula: A equals P times E raised to the RT. So in short, there's no like n equals. We just got to switch out the formula. So let me just put like a little love note. I'm going to feel weird if I say n equals continuous. So we're just going to say interest is compounded continuously. Interest is compounded continue. I don't know how to spell it. It's okay. Good thing I'm not being graded on spelling. Okay, that doesn't even look like continuously, but pretend it does. Okay, interest is compounded continuously. So we're gonna have to use that exclusive formula for continuous compounding. A equals P times E raised to the RT power. So let's go ahead, find the final amount, and then we're out. And according to our pattern, the more times that the interest is being compounded, the more money that we're gonna have at the end with interest. So we're expected for this to be more than when the interest is compounded daily. Well, daily is kind of close to like pretty much that's it. All right. You know what I was trying to say, even though I couldn't phrase it out. Okay, so we have that the final amount is given by the principal, which is 3,000, times E. Okay, E is just an irrational number, raised to the rate. Rate is 0.035, times time, which is 7 years. Okay, so again, the solution is just straight arithmetic. So let's go to the final amount. Okay, so we have A equals $3,000 times E. You don't really need the times, but I'm just so used to putting it. So E is not the main key, it's one of the behind keys. So we're gonna have to do second E. Go back to the earlier video where we talk about how to enter the E key. So it automatically says E raised to something. So raised to this product, 0.035 times 7, close the exponent, we'll hit equals. Let's go ahead, write it. We have, sorry, my Spanish comes out, 3832.863. Okay, so let's go ahead, keep our cool and see if we're gonna round up or down. Sorry, my hand slipped. And in this case, we're gonna round down. So that will give us the final amount is about 38,000. Sorry, it's about 3,000. If it was 38,000, oh, tell me where that bank is. Sorry. The final amount is $3,832 with 86 cents. This is expected to be more than the other one, and yeah, it's a 4 cents higher. So the question was, how much money will there be in the account, at the end of 7 years? There's four. It's a 4-in-1 problem, so we've answered it. But let's go ahead, throw out a bonus question. If you were Panchito, this is an online bank, so you don't have to worry about gas money. If you were Panchito, where would you park your money? Would you put it in a place where the interest is compounded yearly, monthly, daily, or continuously? The daily and continuously is about the same, but every penny counts, so I will go with this guy where the interest is compounded continuously. But in real life, you don't see that. The closest you'll get to continuously is daily. Okay guys, that's my time. Please come back for the last video in this mini series. Thanks.